Hi guys, and welcome to Physical Sciences for Year 10 of the Australian curriculum. In this video we're going to look at the concept of conservation of energy and try and explain that in a little more detail. We're also going to look at the difference between energy transfer and energy transformations. Now, we covered energy conservation of energy in the first video when we looked at James Prescott Joule. Remember, James Prescott Joule did a lot of experimentation with heat, and he built up a relationship between heat and work done. And from this, the law of conservation of energy came through. Now, let's just recap on what the conservation of energy states is that the energy that is put into the system equals the energy coming out of a system. Well, let's have a look at the cartoon below and try and put that into a little bit more of, improve our understanding as to what that means. Now, when you look at this cartoon, it's very, very simple. You've got a girl here who's basically going on an assault course. Now, on that assault course, she's bringing with her all the energy. Now, what we're looking at is the girl and what happens to the girl as she goes through various obstacles. That is the system. As a result, the system is closed. Okay, so we're looking only at what she is doing as she goes through her assault course, as she goes over the obstacles. There is no other energy which is going to be put in. Okay, there's no other energy which is going to be put in from outside of the system. She's not going to be taking a snack or what have you. We're just looking at what she's bringing in, and once she's brought it in, everything that happens to her throughout a set of events, we're going to analyze. So it's now a closed system. Now we notice that we've got energy in. Now the energy in is the chemical energy that she's taken into her body in the form of food. Now what she then does with that stored chemical energy is she then uses it to move her muscles, to climb the ladder, to get on top of the box. Okay, so remember, work done is now occurred because she's taken that stored chemical energy and she's done work to actually raise herself above the ground. Now that she's raised above the ground, she's got height. Now remember, gravitational potential energy is the mass times the acceleration due to gravity times the height. Now she's got GPE at the moment, and it's a potential energy because she's not done anything with it. She grabs hold of the rope. As soon as she jumps off that box, she's now under the influence of gravity. Gravity will then start accelerating her downwards, but because she's on a rope, it's going to swing in like a pendulum. So she's going to have a speed now. Now that speed, and we've got motion, means she must have kinetic energy. So that gravitational potential energy is now converted into kinetic energy. We can calculate that as a half times the mass times the velocity or speed squared. Okay, so she jumps off the box. She's attached to the rope. Gravity is going to be pulling her down. She's going to swing across the river and land on the other side. When she lands on the other side, basically what we'll expect to see is she'll probably still have some stored chemical energy from what she had at the beginning. If it was a finite system, what would happen is she will have used up all of her chemical energy going into gravitational potential energy, and then that energy would have gone into kinetic energy. And what we could then say is that the kinetic energy would equal the stored chemical energy. In reality, that doesn't happen. Okay, what she'll be left with at the end is the chemical energy. She'll have some chemical energy left over, but some will be lost in that conversion from stored gravitational to kinetic. Okay, so from that we can build up a flowchart. A flowchart will show us the various types of energies that have been used in our closed system. Now notice we've got the energy in, which is the chemical energy, and then the energy out with the GPE going to the kinetic energy. Okay, note that the GPE does not equal the kinetic energy, or GPE is not added together with the kinetic energy because the GPE is going to be converted into kinetic energy. As I say, if this was a finite system, the chemical energy at the beginning would equal the kinetic energy at the end. She'd have no stored energy left over. As I say, in reality, the chemical energy in would probably kinetic energy out plus some stored energy which is still inside her. Okay, so when we add those together, they would equal what we started with. Okay, well, have a go at exercise 2.1 from the iBook when we finish this video, and there's a little bit more of an exercise for you to work through on this video. Okay, now the next thing we're going to be looking at is energy transfer. Now, energy transfer basically is when energy moves from one form to another, but the key to it is that there is no change in the energy. The energy is the same throughout. Now, let's take an example here. For example, we've got a Bunsen burner which is heating a beaker of water. So, what energies have we got? Well, obviously we've got heat energy which is coming from the flame. Now, yes, I know that the Bunsen burner will have chemical potential energy, and that's lit. But we're going to ignore that at this point because I'm not just looking at the transfer of energy, and I want to show you or prove to you that in each case that we've got energy moving, but it's the same type. So let's just look at the flame. There is heat in the flame. That is then transferred to the heat in the water of the beaker. So energy has gone from the flame and then it has gone into the water. From there, the water is then converted into steam and comes off. Now we know that steam is hot, so it's got heat as well. Notice in all three situations, the energy is exactly the same. Okay, so as a result, we can call transference of energy because the energy is the same. Now we can put that into a flowchart, which will look like this. Heat in the flame goes to heat in the water, which goes to heat in steam. Notice it's heat, heat, heat. Same type of energy in all the situations there. All right, so if you go and have a look at the iBook or have a look at the video on post, we've put together a dominoes situation which we did in class, and there's an exercise 2.2 from the iBook which is going to ask you to actually look at the energy transference that happens when you knock over a line of dominoes. So check that out at the end of the video, and yeah, it's a good video. The girls did really well putting it together, all those dominoes. It's good fun. You can try it at home if you've got enough dominoes. So that's energy transfer, where the energy stays the same. Now the opposite of energy transfer is energy transformation. Now transformation is basically when we get a change in energy. So energy will change from one form into another. So energy transfer, the energy stays the same. Energy transformation, the energy changes into a different type. Well, let's look at the situation. Here we've got the sun. Okay, now the sun basically can be trapped using solar panels, and we use this a lot in Australia because we've got a lot of sun. Now basically what happens is the sun is nuclear energy, as we know. It also generates heat. So there's a variety of different transfers that we can have. But if we just state that the sun uses nuclear energy, that nuclear energy is then converted into electrical energy by that solar panel. That solar panel's electrical energy is then converted into heat in the water heater. So of course our water heats up. So that's just one example of an energy transformation. Why is it transformation? Because the energy has changed from nuclear to electricity to heat. Let's look at this scenario. Same sort of situation, but in a different context. The sun's energy, nuclear, is then converted to electricity. That electricity can then, from the solar panel, be passed around the country. So we've got electricity moving from the solar panel down into wires. Now, in this situation, we've got energy transfer. Why have we got energy transfer? They're both the same. Electricity going to electricity. They've just been moved from one point to the next. However, what do we use that electricity for when we get into our house? Well, there's a variety of different things that we can add. We can add light, we can add heat, or we could add sound. But notice we've got electricity going to light, heat, and sound. They're all different. So as a result, we've got an energy transformation. So, to recap, energy transfer is when we've got the same type of energy moving from one place to the next. Energy transformation is where we've got energy changing from one form into another. Remember that we stated at the beginning of this topic, energy cannot be destroyed. It can only be transferred or transformed from one type into another. Okay, well, what I'd like you to do is there's another exercise 2.3 from the iBook that you can have a look at. I'd also like you to check out the video which I put on a roller coaster, and we'll look at energy transference as we go through a roller coaster ride. So that should be fun. Okay, well, thank you for joining me, and hopefully you'll join me again and we'll go through our next video. Thanks for watching.